To doing this. This is actually works out to be a really nice Friday lesson. There's not a lot of material to it. You guys probably would be able to graph these on your own and be able to identify some specific parts without even me showing you anything, to tell you the truth. For example, before I get into the whole rational thing, what would you be able to tell me about this graph?
All rise up to.
No. If I wanted to graph, let's just say if I wanted to graph this, what is one important thing you can tell me about that? Y-intercept is negative 2/3, good. All right, what else, baby?
It's not quadratic, or it's just a line.
It's not quadratic or something, okay, all right. You're overlooking something obvious.
Y
equals 0.
I like the 2/3 for your y-intercept, I like that.
X is 0, Y is.
Well,
Yeah, it goes in the order.
what happens if x is 3?
It's non-existent.
It's not existent, right?
Division over 0.
What happens when you divide by 0?
It goes.
It goes berserk.
Yeah.
What happens when you have something that divides by 0? What is that called?
Vertical line.
Vertical, yes, I'll give you that. Oh, got it.
Vertical dash line.
I don't know, we might have had them with hyperbolas.
See, it turns out.
No. I'm not touching you, 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 I'm not touching you. Oh, what?
I know I am.
Oh!
I feel like you're wrong.
No!
I'm rolling these notes, don't say it. I got something to tell you.
Physical harassment?
It's not you. Wait, I got that. Say it.
You guys are killing me!
What is it?
Is it the thing like the Y?
No.
It's the.
No, that's your first letter.
I know it. I do.
You obviously don't know your asymptote from a hole in the ground.
It's just the line under the.
It's the asymptote!
Oh.
What's that?
Oh.
I can't remember what the
I would do that. Wait, what is
It's
that?
not like where it goes.
Did that?
Oh, I tried.
Oh, that's the thing on the side, right? I never
It is very embarrassing. What happens here with a rational function is that you wind up, when you're graphing rationals, you're going to get asymptotes. You're going to get asymptotes. Nice catch this time. What happens here with rational functions is basically any rational function can be written in the form of this. And this f of x, remember, is some function is built of function divided by function. Okay. Now, what this means is that this p of x is another name for some polynomial. Same thing with that q of x. What we're looking at here is you're taking two polynomials and dividing them out. And we're going to look at the graphs of them. Okay. We've already talked about a whole bunch of stuff with polynomials. We did that all last chapter. And then last chapter, when we did polynomials, we had squared polynomials, we had linear polynomials, we had cubics, quartics, all those fun things. And then we are just basically dividing them out and looking at their graphs. What's up? What?
recap. I know hard to remember names.
Okay, Susan.
Does it have to be a fraction?
Same thing, right? Isn't that a polynomial?
No.
It is. Polynomial. It's just a constant. What's up?
Where did that
Made it up.
two? Okay.
It came from my brain.
I didn't know you had one of those.
Me either. It's crazy how it works. So what we're doing here today is we're going to look at graphs. I don't want to go through this. We're going to look at graphs like this. And there are specific certain rules for the two types of graphs that we're going to look at. We're going to look at this first one that's in this rational function form with an h and a k. So you have your y equals something over x minus h plus k. If you remember your AH and Ks were your horizontal and vertical shifts. What you're looking at for your horizontal and vertical shifts now, they are playing roles of asymptotes. You're no longer going to take an equation that's centered around the origin, where h and k would both be 0. You're going to move them left and right, up and down. So what happens here is that you're going to get this vertical asymptote when x equals h, a 0. We'll see in a second. And your horizontal asymptote will always be at y equals k. All right. So what we're going to do here today is we're going to look at some very, very simple graphs. Basically, your calculator is going to be able to do a lot of this for you, but you have to be able to identify asymptotes. Calculator doesn't find asymptotes. You need to know how to find those forms. And like I said, it is very, very simple to do. So I want to look at this function. Y equals -2 over x plus 3, all minus 1. And when I do that, I'm not going to use graph paper to start with. What I want to do is I want to identify where my asymptotes are. I want to find my asymptote. No, the show that you're thinking of is Where Are My Pants? Lego movie. I was trying to go along the line of Where Is My Asymptote? You haven't seen Lego movie?
Next week.
It's actually the best. The best part of the entire movie is when the Star Wars guys show up and Lando is going, "Hey, brother, hit that hyperdrive," and they go, and they get eaten. It's just, I was in tears
I saw it
when I saw that.
And
I
the
was.
second time I only saw the second half, and then there were 3 little boys watching
Yeah,
it.
my kids didn't get the joke, but my wife was like, "Why are you laughing so hard? You don't get the joke. It is priceless when they pull it out." You don't know what I'm talking about.
Can you explain
Anyway, we'll worry about that later. So what you're going to wind up doing with these things, guys, is you're just going to identify your AHs and Ks. When you go through that, they're in that form where your A is -2, your H, what's your H value? You're looking for the 0 of the denominator. -3. You're always going to be looking for the 0. You want to find out what makes the denominator 0. That will always, always, always be your vertical asymptote, no matter what. And then your K value here is what? -1, good. Remember, a lot of times the rules with the AHs and Ks, your K value is always the same, your H value is going to be the opposite sign. Okay? So when I go to look at what this graph is going to be, all I would do is just make a grid. I know I have a vertical asymptote at -3. And I have a horizontal asymptote at -1.
Is that where the H and it's not me, never mind.
Now, to figure out the rest of the graph, what do you think you're going to do?
Graph it in the calculator.
Horizontal? Horizontal is, yeah. Use your y equals table. Use your y equals table.
What was the equation, x plus 3?
Yeah, it was y equals -2 over x plus 3, all minus 1. You can do that fraction bar by hitting alpha y equals. You remember?
All minus 1?
Alpha y equals, yeah, all minus 1. So it was -2 over x plus 3, all minus 1.
They're all fractions.
It's okay. Oh,
An error.
if I look at my graph, notice what I did not change back. My window. Remember how to rechange your window.
Wait, I still have a bunch of dots.
That's fine, you're gonna rechange your window right now. Go to your window.
But like little squares.
Yeah, we know.
Is that okay?
I mean, anyway.
How do you highlight your equals? Is that what it is?
I hit it wrong. What's that?
Why did you put your ass?
I accidentally hit it.
No.
That's all. I accidentally hit it. Those dots are still there because your stat plot is still on. So what I want you to do, if you still have dots on your graph, go back to, you want to hit second, y equals,
Stat plot off.
stat plot off. And then hit back to the graph, and then they'll be gone. And now everything is awesome.
Wait, what do you push?
You want to hit second, stat plot, and then you want to turn it off. You have to hit enter to open the screen, and then just move the cursor over. Okay? And then it should be all right. So now, yes, you're right. Your table stuff is going to look a little weird because sometimes your values, you're going to get fractions, and sometimes you might get whole numbers. So if I was going to go figure out which ones I want to plot, what do you think I'm going to use?
Whole numbers.
Whole numbers, as best as I can. Okay? So if I'm looking at this, I'm just going to bring my table over here so you guys have it in front of you. At -3 is my error because that's my vertical asymptote. At -2, it's -3. Here's 1, 2, 3. At -1, it's -2. At -5, -4, 4, it's at 1. 5 is at 0. And you're just doing this. And you know what that graph is? It's a hyperbola.
Uh-huh.
It's a different form of a hyperbola. Remember, when we did hyperbolas, we had hyperbolas with slant asymptotes. Yeah.
Oh, yeah.
Okay. So what you're looking at being able to do here, guys, is just be able to label out two ordered pairs on both sides of the curve that give you decent numbers. Sometimes you'll get decent numbers, sometimes you won't. You just have to write it down. That's all. It'll help you figure out direction. Okay.
So basically, do we have to look at our
You're looking at the hug the lines, but you still want to plot a couple of points. And that's what I'm always going to do, is plot 2 points on both sides of the curve. I always put my asymptotes in. Okay. You'll be pleasantly surprised that this is really very easy to do. Okay? Let's try it on the way. Let's try this one, and I don't want to use the graph again. I'm not going to use graph paper yet. So I have y equals -1 over x minus 4, all plus 3.
There's a Y.
Oh yeah, my handwriting is awesome. There, you happy? Yeah.
But I had to erase already.
So, once again, when you go to start these things up, just identify the parts. Just like I'm a strong advocate of identifying everything that you know. It makes your life so much easier. Plus, there's a reason why I'm asking you to continually do this. When things get difficult, when we have to graph, like, I don't know, trig functions, knowing how to identify parts can make your life so much easier. Okay? So your A value is -1, your H is 4, your K is 3. Where are your vertical and horizontal asymptotes?
3 and 4.
Which one's horizontal, which one's vertical?
3 is horizontal.
Good. Okay. And then it's just a matter of putting it into your calculator to get some ordered pairs. If I'm not mistaken, it's probably curving like this again. It is. Like that? Okay. And I'll let you guys, like I said, it's just a matter of putting a couple ordered pairs. Can everybody get some?
Does it matter which ones you choose?
Try to make them the clean ones. It's usually whatever ones you can do that are clean. There should always be at least one or two of them. Okay. Then it shouldn't be, it shouldn't frighten you off, I should say. Okay. What are you guys getting for a couple ordered pairs just to make me happy?
At 5, exact 2.
5-2?
Yeah.
I thought you were taller than that.
Oh, wow.
3, 4 also.
Same.
3, 4, 5-2. What about negatives?
Oh,
Or the other side?
man.
Oh wait, you have 3, 4, 5-2. Oh, I see what you're saying. So this one's over here, or whatever.
I'm so confused.
I can't.
On the outside, you don't be scared.
That is the outside.
Be spared.
only got those two back.
It's just table stuff. Let me show you the other one then. There's two types of equations we're looking at today. This one with the AH and K, and then we've got another function. The other function's a little bit different. This is the weirder of the two.
Yes.
A
I don't think it's
plus
half.
B over CX.
You need to make it, you need to make the I for hints the smiley faces.
Now, if you wind up with one that looks like this, you're going to notice that it does not have that AH and K. It doesn't. They're kind of like two linear equations over one another. All right. Think of it as two lines, if you will, mx plus b over mx plus b. Along those lines, there's no exponent. Yeah.
Oh, I wasn't raising
Oh.
my hand.
What's going to happen here with these is the difference now is that your vertical asymptotes wind up at the wherever your denominator is equal to 0. So your vertical asymptote is when you take that denominator equal to 0 and you solve for it. Okay. It's the 0 of the denominator. Okay. Your horizontal asymptote is going to be at the y equals the leading coefficient over the leading coefficient. And I'll have an example here for you in a second, just to kind of to show you how easy it is to pull this information apart. Oops. So if I use this as an example, y equals 3x plus 2 over 4x minus 1. If I use that as my equation, notice how it's a lot different than that a over x minus h plus k. It's going to be a dead giveaway which one's which. Okay? It's a dead giveaway. When I'm looking at this, I know that my vertical asymptote is going to be when 4x minus 1 equals 0. So what is it?
1/4.
1/4. So I have a vertical asymptote. Vertical asymptote, is that x equals a number or y equals a number?
X.
Good. We'll be at x equals 1/4. My horizontal asymptote would be at what?
3/4.
3/4. It's just the leading term coefficients as a fraction. And that's it. Sometimes that fraction you can simplify, sometimes you can't. More often than not, you won't be able to. And that's all it is. And then from there, you just plot that. Yes, I know it's going to look weird because you've got a fraction one, but all you do is label it. It doesn't matter what it is. Okay? You just label it out, and then just use your table function again to graph. Okay? Your table function will allow you to figure out some pretty simple ordered pairs. So if I wanted to graph that, I have vertical asymptote at a 4th. At x equals 1/4. I have a horizontal asymptote at 3/4. If I go to my calculator to see what it looks like, all I have to do is type it in as the alpha y equals. Clear it out. Let's see, it was alpha y equals was it 3x plus 2? Yeah, maybe.
Is there a way to tell what it looks like without using your calculator?
Well, you'll eventually get there. I don't want to. We'll do a little bit more of that Monday. 4x minus 1 then, right? Yeah. So if I look at the graph, go in the other direction than the other two you've done. And just look at your table, get a couple of sets of ordered pairs. And unfortunately, I think since I made this one up off the top of my head again, you're probably gonna get some crummy numbers. But like I said, it's just a matter of just plotting it through. Okay. You should never, ever, ever get any of these types of problems wrong.
They don't laugh
Ye of little faith. Okay.
So then you make two of those.
Yeah.
Even if it's-
And a lot of times, with this style, a lot of times you get some crummy ones, and it's just how it happens. Which one was it? So let's do this one. We'll come back to worry about domain and range here in a second. Probably won't worry about that till next week. So let's do the graph of y equals x plus 1. Do you guys want graph paper or no?
Yeah.
I mean, you can use it. You don't really need it.
I have a whole package.
I mean, I have some if you want. Let's try not to use it here real quick. So let's graph this. We have y equals x plus 1 over 2x minus 4. Go through your steps of how you do it. Obviously, in this case, you're looking at the two polynomials divided out. So that means that your vertical asymptote is going to be when 2x minus 4 equals 0. And I already heard you say it. It's at what? It's at 2. Good. So it's at x equals 2. My horizontal asymptote is going to be at, yeah, good, it's 1/2. Because the coefficient of the numerator is what? 1. All right, so you're at 1/2. So if I go to plot that, and that just matters some ordered pairs. Did you break it? No. Put it in there. Or, I mean, are you guys okay finding ordered pairs? And I believe this one probably did this. Sure. I think. Did it do something like that? I think it's the basic first and third quadrant, I believe. Do you want graph paper or no?
Can we
Oh,
do
yes,
that
graph paper.
without it?
You do without it.
Okay.
Unless I have graph paper. If you want some graph paper, I'll leave it up here by case. Just come on up and grab it.
So we just do our homework on this then?
Yeah, if you want. Some of it was just identifying, some of the first problems are just identifying asymptotes and things like that. So it shouldn't be very, very difficult.